Luis Anthony Ast, the Video Math Tutor, and this is Solving Linear Equations, Part 1, the basics. Now before we get started, I want to suggest you take the time to go over all the basic math lessons and also the Introduction to Algebra lesson. Also, I want you to take the time to read the notes first and then watch the video. This way, it's the second time around, so it's much easier. And with that said, let's get started. An equation is a statement that two expressions or quantities are equal. An equal sign is always a part of an equation. Equations can be true, false, or neither. For example, 2 plus 2 equals 4? Yeah, that's true. 1 plus 1 equals 3? So that's false. Now let's take a look at an equation that's neither. Now let's take a look at the equation x plus 4 equals 9. See, this is neither true nor false because I don't know what the value of x is as it stands. Well, let's assign a value to x. For example, let's let this x right here have a value of 2. So if this x is 2, what do we get? 2 plus 4 equals 9. Is that true or false? Well, it's false. So now let's change that to 5. So if x equals 5, 5 plus 4 equals 9. Is that true or false? It's true. So sometimes an equation is true, false, or neither until you assign a value or you can find a value for the variable. The goal of this lesson is to find all values of a variable that will make an equation true. Before we continue, let's now talk about some terminology. A solution is a value that, when substituted in place of a variable, makes an equation true. The solution set is the set of all solutions. Going back to our previous example, x equals 2 is not a solution to this equation. However, x equals 5 is a solution. And you would write the solution set like this. This is the set consisting of the single element 5. Now, I'm not always going to be saying that. It's kind of worried. I'm just going to write it down on the board, okay, just to make things simple. Example number 1. Determine whether x equals 6 is a solution of the equation 2x minus 3 equals 9. What do? It's actually pretty easy. First, rewrite this equation, but put a set of parentheses in place of the x, like this. So we have 2 something minus 3 equals 9. We talked about this in our previous lesson. This is sort of like a template. And we want x to be 6, so I'm going to replace the x with 6. Now, I don't officially know this is true yet, so I'm going to put a little question mark above the equal sign. Because I don't know if it's true. Now let's simplify. 2 times 6 is 12 minus 3 equals 9. Maybe. Well, I'm not quite sure yet. That's why there's a little question mark above there. Now you might go, come on, Luis. That's 9. Come on. Well, I want to stress something. When you do these problems, always continue until you reach the very end of the simplification. I can go one step further. 12 minus 3 is 9 equals 9. Is that true? Oh, yeah, 9 equals 9. So we don't put the question mark now. We are officially finished with this problem. Now let's write down the answer, formal answer. So you're going to say, yes, x equals 6 is a solution. Okay. Now you can box this or circle it or whatever. For this lesson, I'll just write it out. And we're done. I really want to take this moment to stress the fact that when you're checking an equation or doing substitutions, you're not done until you get to the point where you have a number equals the same number, like we did before, the 9 equals 9. If you don't get to this point, you're not done. And some math instructors will actually consider it to be wrong. All right? So always finish with a step that looks like this when you're doing a check. Right? Equations are said to be equivalent if they have exactly the same set of solutions. Example 2. The following 3 equations are equivalent. Why? Well, they all share the same solution set, which is right here. Now, at this point, don't worry where this came from, how I got the solution set. We're going to talk about techniques for solving in this lesson for these 2, and this is done in another lesson. Now let's take a look at these 2 equations. They are not equivalent because their solution sets are not equal. This one consists of the elements -2 and 1. The solution set over here is just -1. They're not the same, so they're not equivalent. An identity is an equation where the variable can have any value that is meaningful. Identities are useful to state important mathematical properties or rules. A contradiction, or an inconsistent equation, is an equation with no solutions. Its solution set is empty. To show an empty set, you can use either this symbol right here or a set of empty curly braces. The one that's more frequently used is this one, and that's the one I'm going to be using. I just want to warn you that on a calculator, if you see something that looks like this with a slash through it, it's really just the number 0. Calculators do this to distinguish 0 from the letter O. There is no empty set symbol like this on most graphing calculators. A conditional equation is one where only some, but not all values of the variable are solutions. We will be dealing mostly with conditional equations. Example 3. Let's determine if the following are identities, contradictions, or conditional equations. Now I will use this symbol just as a way of separating my different equations if I have several on the board from now on. Okay? For the first one here, what do you think it's going to be? Well, it's a conditional equation. Why? Well, it's only true on the condition that, yes, that's where the name comes from, on the condition that x has a value of 1, because 1 plus 3 is 4. That's why it's a conditional equation. The next one, x plus 3 equals x. What does it say? It says it's a number plus 3 is the same thing you started with. That can't happen. That's impossible. You can't have something and add something to it and then get what you started with. No way. So this is a contradiction. Now this last one, we have x plus x plus x equals 3x. Well, no matter what value of x you have, this is true. If you simplify this first part of the equation, x plus x is 3x. So this is an identity. It's true for all values of x. A linear or first degree equation is an equation in which every variable term is raised to the first power. X to the first, y to the first, z to the first, etc. The word linear is used because the graphs of these equations are just straight lines. But we won't do any graphs in this lesson, don't worry about it. A nonlinear equation is one that is not linear. Now let's take a look at some examples of linear and nonlinear equations. For this first one here, what do you think it is? This is an example of a linear equation in one variable. What about this next one? This is a nonlinear equation. Why? Well, because x isn't to the first power, it's squared. This next one is an example of a linear equation in two variables, x's and y's. Notice they're both being raised to the first power. Over here, what do you think this is? Well, it's nonlinear. You may go, well, wait a minute, x's and y's to the first power. Well, the x's and y's are not allowed to be in the denominators themselves, so nonlinear. Over here, what do you think? It's nonlinear. Ugh, well, why? Well, even though the x's and y's are non-denominators, they're to the first power, because they're being multiplied together, it's actually considered to be of degree 2. You add the exponents when you multiply, right here. For this one, what do you think it is? It's an example of a nonlinear equation, because even though x's and y's are to the first powers, they cannot be exponents themselves. And finally, this is a linear equation in one variable. Even though x appears twice, you say one variable of just x's. You say two variables, you have x's and y's. And you have three variables, x, y, z's, and so on. So, linear in one variable. If a variable is inside another mathematical operation, it is not considered linear, even though the variable itself may be raised to the first power. And you can see that over here. Again, don't worry about if you don't understand completely what these all mean. Just want to illustrate the point that the x, y, z's, and thetas are all being raised to the first power. It appears linear, but they're not, because they're inside another mathematical operation, square roots, absolute values, and so on. Right? The standard form of a linear equation in one variable is ax plus b equals 0, where x is the variable, a and b are constants, and a is not equal to 0. In some textbooks, or some math instructors may state that the standard form of a linear equation is this, ax equals b, or ax plus b equals c. However, I found it's more universally accepted to have it in this form, ax plus b equals 0. And this is the form I will use in my lessons. When you're given a linear equation in one variable that you want to solve, basically all you need to do is change it into an equivalent one that is simpler in form. And continue doing this until eventually you get something that looks like this. A variable equals a number. At this point, they're done! It's easy, right? Now at this point in the lesson, I want to cover the techniques and properties of numbers that will allow us to change the equation from one form into an equivalent one. Now the key thing to remember when you're manipulating an equation is that whatever you do to one side of the equation, you must do to the other side of the equation. Now I do want to remind you that you should go over the properties of equality that are covered in Basic Math lesson number 4. Now in the printed notes, I actually do quickly review these, but the best thing to do is look at the video. There are a few techniques you can use to simplify your equations. The first one is just remove any grouping symbols you see. In other words, just apply the distributive law. Next, just combine like terms. That's pretty straightforward. Also, eliminate or reduce any fractions you see in the equation simply by multiplying both sides by the LCD. Very straightforward. Now, don't forget, any arithmetic operation you do to one side of the equation, you must do to the other. Example 5. Solve the following equations for the variable by adding or subtracting from both sides of the equation. Let's go ahead and use this setup to illustrate our example. I have x plus 5 equals 12. So I'm going to let x be the number of marbles in a canister like this. And I have one just like it right in there. And I have 5 extra marbles in here. That's going to represent the 5. And on the other side of the balance, I have 12 marbles. Okay, I also have some extra weights to compensate for the weight of an empty canister. Just ignore that. Now, my goal is to figure out how many marbles are in the canister. How can we figure that out? Yeah, just count the marbles in here. 1, 2, 3. No, I don't want you to do that. I went through a lot of time and effort to get this thing set up here, so we're going to use it. Oh, sorry. Now, we want to know what's x, but there's extra stuff with it. So let's just remove the extra stuff. So I'm going to just take away 5 marbles from here. So let's do that. 1, 2, 3, all these 5. 1, 2, 3, 4, 5. Well, look what happened. It's no longer balanced. Well, if you take away 5 from one side, you better take away 5 from the other side. So I'm going to take 1, 2, 3, 4, and 5. And that should be... Oh! Aha! So I had x plus 5, did not want the 5, remove 5 marbles. You got to do one side, you got to do the other side, take away 5 from this side. 12, take away 5 is 7. What can we conclude? X is equal to 7. Now let's go ahead and do the same example again, this time with a little less clutter. So I have x plus 5 equals 12. I want to get rid of the 5, so we perform the inverse operation of addition, which is subtraction. So I subtract 5 from both sides of the equation. And I simplify. 5 minus 5 is 0, 12 minus 5 is 7. And continue simplifying. X plus 0 is x, and the 7 stays. So this is my solution to the equation. X equals 7. And here's my solution set. I want to point something out to you. Each and every one of these is an equivalent equation. Why? Because each one of these has this as its solution set. Now, this is pretty much the standard method of solving a linear equation. It's a little wordy, so I'm going to now show you a much faster way of doing this. I like to call it the tutor's method, but of course, a lot of teachers and professors do what I want to show you right now. Now let's do this equation a third time. But this time it's going to be much faster. I have x plus 5 equals 12. I want to solve for x. So I'm adding 5, so I do the opposite. I'm going to subtract 5 from both sides of the equation. Both sides of the equation.